Okay, this lesson for AP is going to be about solid liquids and gases, which sounds pretty simplistic, but AP pulls in intermolecular forces and strength between bonds, not just what is a solid liquid and a gas. But we do need a review real quick about what are the 6 phase changes of matter. So when we say phase changes, we're saying something that starts in one state of matter and goes to a different state of matter. So what are some phase changes that you know of? Well, we have, it'd help if I told it to write. We have melting, which is going to start as a solid and go to a liquid. We have freezing, which is also sometimes called solidification, because not everything actually freezes at a cold temperature like water does. We use water as our basis of understanding because we can see it at solid, liquid, and gas at room temperature. Like in our environment, we can see that solid, liquid, and gas. But the problem is that it has really odd characteristics because of the hydrogen bonding. And so I said room temperature a minute ago, I meant room pressure. We can see it naturally in our environment. And so some things actually freeze at room temperature. We sometimes use solidification, but that's where we go from a liquid to a solid. It's the reverse. We have boiling or vaporization or evaporation. You'll see all 3 of those words. And that is where we go from a liquid to a gas. The opposite of evaporation is condensation. And that's where we go from a gas to a liquid. The last 2 are the 2 that we don't think about as often. So one of them is called deposition. You guys see this in nature on cold, frosty mornings. The water vapor goes straight from a gas to a solid. And then the last one is called sublimation. Water does not do this naturally on its own, but dry ice does, and sublimation is where it goes straight from a solid to a gas. Those are what we call phase changes. In order for these phase changes to happen, there has to be energy absorbed or released because we are breaking and forming intermolecular forces. And so this whole section is about what happens when it goes from a solid liquid to a gas. We're not quite into talking about the energy changes. We'll talk about that later. So solids do not have enough kinetic energy to move freely. So they pretty much just stay in their place and they vibrate in place. The things that are holding these in fixed positions are your intermolecular forces. So we saw the other day, we talked about water. Water up here, the reason it is in this structure is because of intermolecular forces, the hydrogen bonding. And so solids cannot be compressed because if you compress them, they're going to find those areas of weakness where maybe if it's an ionic compound, then the opposite charges get close to each other and they break, or they're just areas of weakness. So when we compress them, they break. And these crystalline solids that have a repeating 3D pattern is going to be like your salt, even ice has a repeating pattern. But there's something called amorphous solids like wax and plastic that are a little bit more disordered. But they are still considered to be a solid. That's just the crystalline has that very specific structure. Well, amorphous, the prefix a means without, morph means shape. So without shape is going to be the wax or plastic. Liquids are going to be closer together. They do have enough kinetic energy to move around. But if you look at this picture, this is an example going from here to here. And so some of these are still sort of in fixed positions, but then some of them have started shifting around. Liquids do not retain their shape and they cannot be compressed. Again, if we try to compress them, they're just going to shift around and pop out of your hands. And so the compression isn't going to work. They can shift around themselves. And there's not much space to compress. So if you look in here, there's not a lot of space in between these particles to be able to compress down. Temperature range at which a substance is liquid is determined by its intermolecular forces. Most of our alcohols have very low temperatures when they can be go from a liquid to a gas. If you use hand sanitizer, you are using an alcohol-based substance, and it evaporates just with the temperature of your hands rubbing together. So that's a very low temperature compared to water. And then a solid and a liquid of the same substance are going to be approximately about the same size since the particles are close together in both states. Again, if I look at this and I found the area that this was taking up, it's going to be pretty close to this. There's not a lot of difference. But gases have a ton of kinetic energy to overcome the intermolecular forces. Because of that, they can spread out really, really far, and they have a ton of space in between, and so they can't be compressed. There is no rhyme or reason to where their particles are, so there's not a regular pattern. And we're going to talk in next section about how pressure, volume, and temperature affects the collisions of your particles. So AP is going to ask you to do a lot of particle drawings. They love their particle drawings. And so this is draw the CO2 molecule after sublimation occurs. So first of all, you have to know what sublimation means. And remember a minute ago we said sublimation is going from a solid to a gas. It skips through those states. It says the diagram below represents 5 molecules of CO2 in the solid state. And it wants you to draw them after sublimation occurs. So typically you're going to draw a little arrow. You're going to make a box that's about equal size because this is representing the volume of the area that you have. However many it tells you to start with is how many you need to draw over here. So in these I have a thing that looks like a piece of candy. I have 2 whites on either end and 1 black in the middle, which is representing the CO2 Lewis structure, but in model form. And so I'm going to draw 5 of those, spread them out. And there doesn't have to be the same direction or anything. They can do whatever they want to over here because gases are able to spread out and move around. And I'm going to draw 5 of them the best I can. What type of solid is quartz? It says quartz is a mineral commonly found in Earth's crust, consists mainly of silicon dioxide. The structure of quartz is shown below. And it's asking what type of solid quartz is. Well, we have 4 types of solids. We talked about them in our last lesson. We have ionic solids, covalent network solids, molecular solids, and metallic solids. So quartz, it tells me its formula is SiO2. Well, if I look up on the periodic table, I find out that Si is a metalloid and O is a nonmetal. So I could really easily look at this and be like, oh, it's a covalent compound, so it's a molecular solid. But we have to be careful because we have that covalent network solid. And that is what this is. Because any of these bonds where it has a metalloid bonded to a nonmetal, that's considered covalent network. Most common they're going to give you is either carbon in its elemental form or silicon dioxide. That's the 2 that AP seems to really like to test you guys on. Which of the following phase transitions is illustrated in the diagram above? So again, I'm looking at it and trying to decide what's happening to the particles. Are they getting more or less organized, more or less structured? So over here, this is going to be representing a liquid. Over here, this is a solid. Again, if I found the area around this versus the area around this, it's going to be about the same. They're taking up almost the same amount of space. And if something goes from a liquid to a solid, that is freezing. If it was a multiple choice question and you didn't see freezing, then you could choose solidification because they mean the same thing. And that's it for this lesson. This lesson's pretty straightforward, but you do have to understand that these particle drawings are going to be something we deal with all year long. And so you want to start getting comfy with recognizing those and being comfortable with drawing those.